Hey everyone, welcome back to the stream. I am Josh Justice, aka Coding It Wrong, and as I often say, you can watch the stream today and then you can decide if you agree that I am in fact coding it wrong. Glad everyone is joining live or on the recording afterwards. I'm still out here in Louisiana working from the month of December, so that's been fun. Today we're jumping into a new topic. So we've been doing a lot of test-driven development in different frameworks, React Native, and today we're zooming all the way down to the individual function level. So we're going to be doing some test-driven development on a function, but not just any function, and not just an easy function, but one that's a little bit crazy, and I don't even know exactly where it's going. So test-driven development is going to be great. I'm not just showing the process, I'm going to actually be using test-driven development for me to learn how we're going to build out this code. So it's going to be great. If you're on the stream, please say hello in the chat. I would love to say hello. And there, Ken Bear says hi and waves hello back. Everybody else, please ask questions and give me feedback and ideas as we go through the stream. I love to interact with folks on the chat. One quick heads up before we get started. The reason that I've rescheduled the stream this week from Friday to Thursday is another Twitch event that's happening tomorrow. It's ByteConf React Native. Let me zoom this in so you can even read this a little bit on the stream. You can hit them up at byteconf.com, but if you're a React Native developer or are interested in React Native, you should check it out. It's streamed on Twitch for free tomorrow. I think you can kind of sign up to get notified on the ByteConf website, or you can just kind of check them out on Twitter and see what's going on. Some folks that I know and respect a lot are going to be speaking. It's going to be great. I'm in the Central Time Zone right now, so it's starting at 11 a.m. So think about checking it out. That's where I'll be, and I'll be interacting on the chat if they allow it. And if not, in Reactiflux and on Twitter as usual. So yeah, check it out. Join me tomorrow for that if you want. So let's talk about what we're going to be test driving today. If you're old like me, you may remember a video game called Myst. So Myst was a crazy puzzle game that was very revolutionary in that it was using 3D pre-rendered, but 3D pre-rendered graphics, which, at the time, what time? 1993? Many years ago, I can't do the calculation in my head, was really groundbreaking at the time. It was a really interesting puzzle game. I, in retrospect, have found that I find those puzzles a little too mind-bending, so it's not my favorite type, but it's stuck with me. And one interesting thing that came out of Myst was there was a series of novels that were written afterwards, and it's all about this world where you can write words in a book, and it creates a world that you can teleport to join in. So just the act of writing creates a world. This came back to mind recently as I was looking into, like many of us that are into programming, you might have gotten in through an interest in video games. Many people aren't into video games as well, but some of us are. And so I've always been interested in potentially making video games. But when I got into 3D modeling software and just 3D game engines, it was just very complicated. And I felt like I was working at this very low level of abstraction where I have to move stuff around and place it. And just the idea of Myst came back to mind for me. I would love to be able to write a description of things and have it create a 3D world that I could interact with. That would be really, really cool. And so I started to brainstorm. I've had this idea for a few years now about what this could be like. And it's led to something that's a bit like natural language processing. Now, if you're into machine learning or natural language processing, I'm sure you will not agree that that's what this is. But I'm starting at something very small and very approachable. Not WebGL. We're actually not getting into the 3D modeling part just yet, Ken Bear. Maybe in a future stream. That would be kind of cool to get into it. But for right now, here's an example of the kind of thing I want to be able to do. As a first step, I want to be able to write very large red dog and have it turn into a JSON or JavaScript data structure where it identifies that the word dog refers to the type of thing that it is, that red refers to the color, and the very large with the adverb, whatever part of speech that is, the very is a modifier on the large, so that refers to the size. And so if we could do this first transformation, then we could do additional transformations to ultimately turn this into actual 3D objects. I think that's the theory, that's the idea. And if nothing else, this will give us a fun bit of code to exercise and test out. This could get, if anybody who knows anything about natural language processing is that it's incredibly complex and maybe even futile, maybe even foolish to tackle. And again, I'm not looking to be able to handle just any sentence that someone makes. It's still a structured thing, but I'd love to be able to write something like this, just kind of like prose, just kind of write these things out and have it turn into some kind of data structure that could be used for 3D modeling. I haven't fully thought through it. That's part of the point of test driving this, is that I haven't fully thought through all the features that I want and all the syntax and figured out what is or isn't a contradiction, but we're going to test drive it out together and see. So maybe that description makes sense, maybe it doesn't, but as we go through and write out the examples in test-driven development, I think you'll see what I'm trying to get at. In coding this, I thought about doing this in Jest, which is, of course, a very popular testing library and is all in one, and it would have been perfectly fine for this purpose as well. I am a bit more familiar with Mocha, just from my background as well as my current client project, so I decided I'm going to go with Mocha and Chai and Sign-On. A while back, I set up this library, this project that's linked in the notes called Mocha Sandbox. There's just an empty project that's pre-configured to run Mocha, Chai, and Sign-On tests. So you can download it. It's linked in the notes down below. You can download it. I've already duplicated it and made a new project, but I haven't made any changes to the files or tests or anything like that. Everything we're doing would apply almost exactly the same to Jest, just some of the matchers or expectations are a bit different. So yeah, with that, let's jump in. Ken Baer says, I just finished an AI final. Sitting back and letting you deal with the NLP sounds nice. That's great. Well, you will be, I think, very surprised at how little I'm actually trying to do. But that's the interesting thing about a test-driven development process is we can build it out using the simplest possible approach. And if we get to the point where it's like, this is just not doable, like this is not working, you can keep that test suite and use it for a refactor that allows you to substitute in a much more intelligent backend that would handle it for you. So that could be interesting. Maybe this will be an excuse. Maybe in a future stream, I will finally learn about machine learning and what's involved in there. I just know about the funny things that Janelle tweets on Twitter about it. I'll link to her later. I forget her last name, but it's hilarious. All right, cool. Let's actually talk about programming. So, got this project. Again, this is my clone of that Mocha Sandbox. You can download, I've already pushed up the natural language project as well. So if you're checking the stream afterwards or the recording, I'll push up the changes we make today so they're available there. I still have my kind of sample test and file here. And I was just kind of making sure that the test still ran fine. When you're running this project, you'd run yarn test or npm run test. And then you can pass this -- watch to keep the test running. That's an approach I like to do because you just get very quick feedback on the changes you're making. And for a low-level test-driven development, working on individual functions like this, it's really nice. So you see that we've got a test in here for this toggle class with a bunch of cases, and it displays in this nice hierarchy. It's really nice. So let's now delete that. Let's delete this toggle file. Just a little sample. Toggle test I'm going to keep in here just in case my brain stops working and I forget how to write a test. I am in Mocha every day, so that should be fine. So let's say, so we've got this file, this test, and what are we going to do? I know what a before each is. I can remove that. So what are we going to call this? Is it parsing? I guess it might be parsing. Let's say we're describing, we want a function, we're going to call it, let's just call it parse. I don't know. The library would have a name, but maybe this function is just called parse. So we'll say import parse from ... source parse. Just be a file. So we're going to describe this parse function, and we're going to start, if you haven't caught the previous streams or are not familiar with test-driven development, we're going to go through a cycle called red, green, refactor. So first we're going to write a test and watch it fail that specifies some small piece of functionality we want to happen. Then we'll go from red to green, where we get the test to pass to become green. And then we're going to refactor to make changes to simplify the code, to improve it and make it better and more maintainable. So we're going to start at this process, and we're going to build out some of the simplest things first. Okay, so let's think about this. So if we have probably here, I'm going to have just a bunch of examples just directly under the describe here. So let's say, the simplest possible example I can think here is if we pass it an empty string. Well, let's not go to that because that gets to the idea of having multiple objects. So let's just think about one object. Do I want to go with dog? Let's go with dog, because a dog as a living being has a lot of different types of attributes that we could have, keys and values for. Plus, I went to, I'm not charging for this, so I can say Clifford. Clearly, this is based on Clifford, the big red dog. So maybe Clifford can be in our example for here. And if I ever decide to monetize this, then we'll have to change to something less copyright infringing. So cool. So what's the basic case here? I don't know how to describe it first, so let me write out the code that I want, and then maybe I'll be able to name the test based on that. So we'll say I want to take let's list it as multiple lines. So let's set the input here. Say the input is just dog. Nice and simple. I like dogs, so that would be great. So if we do parse input, and we'll just do output. Maybe we won't have this on multiple lines in the future, but this helps me think about it. So then we're going to say expect output to, and I think we want to, it's going to be an object. I think we want a deep equal here. So what do we expect the output to be if we pass in a dog? So I want an object that just records in some field the type of object we're doing. I had said type in here because it's not everything's a living being. So the idea is it's just what's the type of object. I might want something else in the future, but that's fine for now. So let's just not think through it, and let's just say we want type of dog. So what this is doing is this is taking just a string, and the translation obviously is very, very simple at this point, but we're taking just an undifferentiated string, and we're saying as an output, okay, we want this turned into an object. This is actually some kind of data structure that's describing something with keys and values that we can use in a bit more of a useful way. And when it is just one string, it's very easy. We can say it's just type dog. One interesting thing to note, if you haven't been around testing so much, our test is following this structure here of what's called arrange, act, assert. This is a very helpful way to think about tests, where first you kind of set up the state of the world before you execute your functionality. Then you act on it, so you run the production code that you want to do, and then something happens. So you're making an assertion, or with our approach here, an expectation set on the results. In our case, this is a simple function that takes some input and returns some output. So we're not going to get into any kind of mock objects or anything like that, or mock functions. It's going to be very simple. So we're following arrange, act, and assert. And so I guess, for a test name, like what am I testing? Like you could say it parses dog, but that's very, very specific. That's not, we're not writing a library to parse dogs. We're writing a library to parse kind of general language for different kind of useful things. So let's think about what we're trying to do here. Really, it parses a single word that is a type of object. It parses a single word that is a type of object. That's the very simple case we're handling here. So let's do it. Let's save this and see if I need to rerun my test runner. That looks like a yes. Or at least it says, cannot find module source parse. So I need to create my production code here. Let's do, this is a very, very small steps I'm taking now, but it's a good idea when you, in test-driven development, to just write only enough code to fix the current error. That way you're sure that your tests are really driving you to what you need. So we'll save this file. Looks like our test runner might need to, maybe if I save the test again, it'll rerun. All right, so now we're getting a red failure. Now it says that parse.default is not a function, which is not totally obvious just from reading that what's happening, but as you might expect, we need to export something from this module. So let's do export default function. I'm going to name it parse. I've heard that that's a good idea. In general, we've got our linter going on. Is our linter? Okay, the linter doesn't care about that. And it looks like, again, we're going to need to reload the test file. It says parse default is not a function. I think it's getting confused, so I'm going to stop and rerun my test suite. Sometimes various different kind of testing tools can get confused there as files change. All right, so now we're getting a more useful error. If you're on the stream and you want me to decrease the font size, let me know, because that's kind of wrapping a lot. But what it's saying here is we expected undefined to deeply equal type dog. So what is the simplest possible functionality to do here? I'm doing test-driven development because I don't want to have to think about all the different combinations of adjectives and adverbs and multiple things, and even I want to describe the relationships between things, that things are near other things, like spatial organization, and I don't want to try to solve all of that at once. I want to solve it one piece at a time. So we want to do the simplest possible solution that we can. Well, the simplest possible way to pass this test, and this is something that is often surprising to new people with test-driven development, is just to return type dog. And now the test passes. So obviously this is not going to be our ultimate implementation. The very next test that we write is going to prove that this is not enough. But we want to do this because we want a test to force us there. We want to make sure if we need a function that's more complex than this, we want to make sure we have tests that are driving us there. And it may not feel like you need those small steps at this point, but at least for me, as we get further and further into this coding, I'm going to need the safety of having tests that are telling me what I need to do and helping me build just enough code for the next step. So we're passing the test right now. So let's move on from there. So next it can be useful, and I don't always do these steps this small for real production code, but I will now for learning and as a way to kind of test myself to practice test-driven development. what I found is that if you don't take the time to take these small steps when it seems unnecessary, you're not going to be in practice to be able to take the small steps when it's really necessary, and you're going to end up in the situation where you're writing lots and lots of production code and things are failing over and over again and you just feel stuck. So I would encourage you to stretch yourself, to try something new by taking these red green refactor steps very seriously and taking as small steps as possible. So what's the next step? We could say parses a different object type. So the smallest kind of change that we can make to go from here is to have some different kind of thing. And I'm not going to include arrange act assert again. I'm just going to kind of show them out here. And in fact, I think I will keep the input on a separate line. But I think parse input, I think I'm going to put down here because that's going to get longer. So I think this is okay. So let's say cat will be fair to all parties here. So if the input is cat, the output should be type cat. So now we're getting an error. It's running through our whole suite, and the first test about parsing a single word is passing, but the second test parses a different object type is failing. Expected expected cat and got dog. And if you're expecting a cat and you got a dog, depending on how you feel about types of animal, that can be very frustrating or very discouraging. So let's fix things here. So what's the simplest way to get both of these tests passing? Well, we're sending in the single word, and we're sending out an object that just has that in the type property. So what we can do is just say input here, and say return type input, and I think that'll work for us. We could do an if-else, like sometimes folks that really encourage the small steps in TDD encourage having an if-else, but I think it's okay. I mean, clearly this is a good step that makes sense to take. So we save our file, and it passes. All right, so we've got two different types of single words being handled, so presumably any number of other types of single words that we add would be handled as well. And from looking at our implementation or knowing our implementation, we know that would work. I see I haven't renamed my test file though, so let me do that. Even the convention here, like usually when you have a test that's corresponding to an individual production file, it's typical to say parse.spec.js or parse.test.js. See that Visual Studio Code changes the color even. Notice that I have made up in my tiff with Visual Studio Code. I'm willing to forgive it enough now, at least to use it for today. So I'm so indecisive. I can never decide what editor I want to use. But today is Visual Studio Code because there's tons of upsides to it. Okay, so for our parse spec. So what else? The next thing I can think of would be to have some kind of attribute. Some kind of attribute that we apply here that it recognizes and it could tell what it is. So this, I think, is going to make things significantly more complex. So let's go into that. I don't need to copy and paste. Goodness sake, I can type out a simple test. Parses an attribute. Parses maybe a simple attribute. Actually, you know, before we go there, I have an idea for something else. Ultimately, I'm going to want to be able to have multiple statements. So I think I'm not going to add any tests, but I think just thinking about it now, I don't want to be able to just return a single object type. I think I actually want to change these tests now to return an array. I want, for a string, I want to be able to return a number of different objects that are recognized from it. And right now, we're just returning one, but I already know that that's the format that I want to use. I guess in this first verbose test, I'll put it on multiple lines. But then for the others, I think I'll probably not. So let's run that, and that's going to break both of our tests. This is not strictly TDD, but this is just what I feel like doing right now, so let's do it. And I am changing the test to get the failure before I do things right. Very frequently at work on the Vue.js project I'm working on, we run into situations where we've written functionality and then we write the test afterwards, and the test is passing, so we feel good, but it turns out that the test would never fail. There's something about the way we've written it that it's always going to pass, so it's not helping and it's not giving us safety. So that's one reason that it's good always to make sure you get the test failing before you make it pass. All right, so we want that array of objects, and for right now, we still don't need to do any looping or anything like that. Simplest way to do it is just to return an array, but now we've at least got the contract right. So I'm not going to need to come back through here too often to be able to change all the previous tests. But I think I do still want to do the attribute next, so let's do that. Parses a single attribute. And again, I think this is going to get complex. Big dog. Big. Let's do color first. Red dog. Expect parse input to deep equal. And you know what, I might even copy and paste this because we're going to need this a lot. I'm just going to copy and paste this down here with an empty input. It parses. It's pretty much always going to parse, so we'll just leave that there. All right. So input red dog. Expect parse input to deep equal, what do we want it to be? We want to say type dog still. And then we also want to say color red. So somehow, we don't know how yet, somehow we needed to know that the red is a color and put it in there. So now we save. Oh, so this is interesting. I hadn't specifically thought about what went wrong. But right now, based on the way we've implemented, we determined that the type is red dog, instead of determining that the type is dog and the color is red. So we're good here. So now we can decide what to do. We could, looking at the code, we could determine that the first attribute, if there's two words, the first word is an attribute. And right now, color is the only attribute we're doing. So thinking about what's the simplest way to pass this test, I think we're just going to assume that any attribute is a color red. So let's work on that. Let's write the simplest possible code to pass this test. Okay, so we've got our input. So it looks like what we're going to need to do is going to split the string. We use Lodash a good amount, so I'm not sure about plain JavaScript. I assume there's a split. Yeah, there's a split. No, that's a symbol. That's not what I want. I want string per type split. Cool, that's what I thought. Yeah, split and pass in the delimiter. All right, so we say tokens is equal to input.split. We'll split on a single space because that's what we have, and it's the simplest possible thing we can code right now. So now we have two tokens. So now we do need to detect that it's always the last token. The way we have it coded right now, the last token is the type. Now this is different in English versus in other languages, and so this is something we could always go to in the future. This thing could be configurable to detect or be told the locale you're in, and maybe in French, for example. I learned a little bit of French a long time ago. In French, if I remember, the noun tends to come first, the direction you're looking at me, the noun tends to come first, and then afterward you have the adjectives. So you would write the equivalent of dog red. My brain's trying to decide if I know dog red in French, and I don't, so we'll just move on. But for right now, we're going to code it out this way. And again, writing that's... See, this is one of the many rabbit trails you can go down if you're not trying to build out one simple piece at a time. So I find that test-driven development really helps a lot with that. So what we have here is the type is the last thing here. So I think that's tokens. In fact, let's put this on a different line. Type equals tokens, and then if I had Lodash, I could do last, but I think these days it's still tokens length minus 1 to get the last type element. And let's say color, because again, we only know about one attribute called color right now. So what is the color? So the color is if, we'll do a ternary operator here. So tokens length greater than 1. So if it's greater than 1, then the color will be tokens 0. Let's not think about this too hard. And then otherwise, it's going to be undefined. I think that's going to break some tests. I think that's not good enough. Well, let's see. Let's run this and see. Yeah, check it out. So if we add a color there, and we say undefined, it's still going to have the attribute on there with a value of undefined, but the way deep equals is working, it's actually making sure that that property is not there at all. So let's do this a bit differently. Let's say const object. So we know we're always going to have the type. And let's do that. So we get the type, assign it on the object, and then we can just say if, actually I like the readability here, ternary is not always the best. So if tokens length is greater than 1, then we can say object.color equals token 0. And I think that will actually work. And then we return, an array with object. All right. Let's see here. Scroll to the bottom. And it's passing. So if you're running the numbers in your head of how I'm doing these calculations, like you can probably determine that this is pretty fragile and would break easily. What would be a good next step? And this is something, it's not always obvious, it's not always black and white what the next step is. Some TDD exercises, the input is a single number, a single integer. So in that case, it's often pretty obvious. You just start at 0 or some reasonable starting point and go up from there, and you just skip numbers if you know that they're already going to be handled. In this case, there's multiple directions that we can sort of expand our input. So I'm making judgment calls about what I think would be most useful to drive us toward. Get a little product placement today. Good times. All right, cool. So that's a single attribute. Actually, I could have hard-coded the color of red, but I didn't feel the need to do that. So we don't need another test to confirm that we have a different color in there. So let's do another type of attribute. I think that'll be good. That seems natural for what to do next. So let's do a different attribute. So if we say big dog, we have a type of dog, and then size is big. I can much more easily think about the next piece of functionality I want than how we're going to implement it, how we're going to make it work. And so I can run this and see what happens. So we're being told instead, because we hard-coded color as the one type of attribute, we're being told now that we've said that the color is big. So like, that's not great. That's not what we want. Oh, I want to do one thing before I keep forgetting to do. Let me disable this test and go back to green here. In case you haven't used deep equal before, well, I guess this is Chai. Chai has that. Jest has this as well, just a bit of different syntax. So when you're comparing objects or arrays, if you said just 2 equal, we would get an error. So check it out. We expected array with object type dog color red to equal array of object with type dog color red. I do wish that it kind of compared these together a little bit more easily. So we can kind of contrast, but if you think about this, these two are in fact the same, and they were working before. So what does deep equal do? Well, deep equal compares all the array elements and all the object properties to see if things are equal, whereas object in memory. And because we're creating this array and this object as literals in the test here, of course, these are not the same objects that are created over on our production code. So when you're wanting to check like the structure of an object or of an array, deep equal is often what you want. And so that's what makes it work there. So that's why we're using deep equal. And we get these nice comparisons as far as what's going wrong, which is great. Okay, so it says here, so we have hard-coded the attribute that we're detecting to be color, but instead, because this is the word big, it's the attribute type is size. So now we're at the point where some intelligence is needed. Our code somehow needs to know that red is a color and big is a size. And so this is the kind of thing where maybe some kind of natural language processing using machine learning could automatically do these things or something like that. What I think, that direction is not the direction that I want to take things right now. And so I'm willing to have this library come with a dictionary of possible things. Like ultimately, of course, we're going to need to implement this in a 3D modeling software. So we're going to have some set of things. And unless the code is dynamically searching free 3D asset libraries, which could get dangerous, we're going to have a predefined determined list of things. Even Scribblenauts, the famous game where you could just write whatever you wanted and it was there, it had a finite, at some point it was finite number of things in it. It was just running a Nintendo DS, for goodness sake. So I think having a library here would work. So let's hard code these in for now, and then let's think about how things would work. Then we can kind of decide if that's the interface we want ultimately. We can do that refactor step. So we've got the red where our test is failing, and so let's make it green now. So in this file, just hard-code it into this file for right now. Let's just create a variable. We'll call it possible attributes. So what kind of possible attributes do we have? We have color, and we have size. And so what are the possible values for color? Well, we have red, and for size, we have big. And that's the only ones we need right now. So my idea here is that this is a config file. This is a configuration of the kinds of attributes that we can have. I guess probably it would be a good idea to have the type of objects as well, but our test is not driving us there yet. So we have this config object for possible attributes and their values that we can use. So let's save this. The test, of course, is still going to fail. So what do we do now? Well, if token length is greater than 1, that's still happening. We just know that instead of assigning to .color, we might assign to a different attribute as well. So what can we do? We can go through here and say if token length equal to 1, we could say possible attributes for each. That's JavaScript, right? We'll find out. Oh, Visual Studio Code is telling me. Yeah, JavaScript language basics. Well, making me feel good about myself there. I use Lodash. What am I going to do? I don't know how to use JavaScript. So for each element, but I don't want element. I want the key and the value because that's the way I've structured it right now. And we could always refactor that in the future. But let's look up for each in here. Callback, current value and current index. Yeah. So there we go. So we can take. We could say values and then key or attribute name. Yeah. Possible values. How about that? Yeah. So as we're looping through this this object, we're going to get the array of possible values and then the attribute name. So then we can say if, now is there a contain, I'm going to end up reaching for Lodash quickly here because I'm so helpless. Includes array prototype includes. Yeah. Okay, cool. So we say if possible values includes. Actually, let's get here. Const value. So this will make it clear. So we're saying the token at position 0 is the value, and if possible values includes the value, then what we want to do is take object attribute name equals value. So if we find that string in the list of possible values for an attribute, that's the attribute that it should be saved on. We're not doing any edge case handling right now because a test hasn't driven us there. So let's think about that. Let's hold off. And for right now, let's see if the test passes with this minimal code. Wouldn't be surprised if I've done something wrong. Yeah. Possible attributes for each is not a function. Oh yeah, because it's an object. So let's see here. I think I want keys, right? Let's Google this. Go to the Google. So JavaScript iterate through key properties and values. Actually, yeah, just the keys. That's probably a good idea. Okay, so we'll just do so possible attributes. Let's say here const attribute names equals object.keys possible attributes. I'm glad I have a test here and I'm just writing a little bit of code at a time, because if this was failing as a part of a bunch more code that I've written, that would be kind of discouraging. So I think this will get us the attribute names. So attribute names for each attribute name. Then what we'll do is possible values equals possible attributes, attribute names. I'm starting to feel like maybe these aren't the best names for maybe this object, but let's see here. Cannot read property includes of undefined. Okay. So possible attributes. I'm getting all the keys in possible attributes. Should be color and size. And then attribute names for each attribute name. Let's log this out. So I will definitely use console.log attribute names. Let's see here. Yeah, color and size. So let's log out the possible values. Color and size. So this is interesting. What am I doing wrong? There's something obvious I'm doing wrong. Ken Bear or others on the stream, feel free to tell me what I'm doing wrong here. Oh, in both cases it's undefined. Possible attributes is an object. Oh, attribute names. Instead of attribute name, that's what I want. I should be using TypeScript. Oh, actually, attribute names is valid as well, but probably TypeScript would have saved me there. Okay, cool. Now things are passing. This is great. Okay, so to recap, after I got confused there, we're going through, we're looking up which attribute to put a given value on for the object. And so now we're able to detect big and red. So let's make sure we can detect both. I think the code actually will already handle detecting both. We didn't like artificially make it not. And so let's do that. So let's say, let's copy and paste. It parses two attributes. So I'm going to be able to parse two different attributes. Big red dog. Big dog. Dog, big, color red. Incidentally, just like I think JavaScript might keep track of the order of the keys you have, but deep equal is not going to care what order of keys you use. So that's fine. You don't have to worry about that, which is great because that's not a detail that I care about here. Okay, cool. Big red dog should turn into big red dog, but it's not actually working. Okay. What have I done? Okay. Parses two attributes. Expected type dog size big to deeply equal an array 1. Is that an array 1 inside an array? I'm not actually sure. But yeah, actually the output here says, oh yeah, the color is not being set. That's really interesting because the color is set up here just fine, but now as a result of this loop. Oh, this is great. See, I didn't need to think ahead about this. The reason it's not being handled is because we're not looping through all the attributes. We're just doing the one at index 0. So only the very last word is being used as the type, and the very first word is being used as the one attribute. So this is great. We now have a test. I didn't think about this in advance, but we now have a test that's going to make sure we're looping through all the attributes. And I didn't think we would need to. I forgot. So instead what we're going to do is, so if token's length is greater than 1, instead what we're going to do is do a loop. What's the best way to do this loop? Let's say, probably we can do some slicing or splicing, one of those things. Slice, that's right. We want an array, a slice. Now I'm never going to remember the attributes for this, so let's see. The beginning and the end. The zero-based index at which to begin extraction. So that should be, the attribute should be at tokens slice 1. So this will skip the, wait, no, that doesn't make any sense. Nope. Attribute starts at index 0, and then it ends like extract up to, but not including end. A negative index can be used, indicating an offset from the end of the sequence. Slice to -1 extracts the third element through the second to last element in the sequence. So yeah, so go to slicing 0 to -1 is going to get the attributes, basically everything in the array except for the last element, and that'll give us the attributes. And then we can do attributes for each attribute. I guess I called it value. Yeah, value. Yeah, so now instead of just one value at index 0, we're going to look at all the values in here. So let's think through this. This is a little dense, so let's separate it out. Attributes for each. I'm not sure quite how to space this. I'm not really happy with anything, so let's just leave it like this. So we get all the attributes. For each one, we get the value. Let's call this attribute values, just because we've got attribute names and attribute values flying around. So for all the attribute values, oh, and we're getting the list of keys for possible attribute. Well, let's come back to that. We can refactor that out, I think. Getting the attribute names, we loop through those, and then we're getting the possible values for that attribute, and we see if it includes the value we have. So I think this loop will work, and it does. So this is great. So we've gone from red to green. Now I see actually a refactor we can do. These attribute names, we only need to retrieve once from the possible attributes. In fact, we could even just do that up as a constant inside of here. So let's make that one change out here, and then rerun the code. And we're still good. So I think that's right. I think all this is dynamic. Yeah, so we're creating the object, and then we're getting the attributes here. And at some point, we might refactor to make this another function in this file that's not exported to handle those attributes, but let's hold off on that. I feel good enough about this now. Although, I am tempted to put a comment on it. Let's wait, though. Let's wait until the next thing we need to add, and then we'll go from there. All right, so we're now parsing two attributes. So now one thing we could think about, well, I want to have different types of value for the attributes, and I want to make sure that we're covered. So let's add one test in there just to make sure that happens. Like, I don't want to add the functionality without adding a test that does it there. So let's say, copy this test for red dog, and we'll say blue dog. Color blue. Parses a different value for an attribute. Okay, and it's not found because the app does not recognize the color blue right now. So let's just add that in. Blue. And now the test passes. So this just kind of confirms that we don't have a single value type that corresponds to each attribute. We can have multiple. So that's good. All right. We could start to think about error cases, like what if a word is found that's just not handled? I don't really know about what kind of error like reporting or something like that I want to do, but we could at least make a test to document what's happening right now, which is I think that probably the words are ignored. So let's just make a test to document that, and we can maybe even leave ourselves a to-do comment to know that we might want to change that in the future. We could say it skips unrecognized attribute values. So we could say a quizzical dog, and then we expected the quizzical red dog. Okay, we'll add a color in there to make sure it doesn't just bail out entirely. And we'll say we do want to know that it's a dog and that it's red, and then quizzical is just skipped. I think deep equal will ensure that's the case. Let's try it out in a minute here. We run this test and it works, so this works here. Now let me see, I forget about deep equal if it ensures that we have all the same attributes or if they just include it. So what if I'm just checking for dog? That will actually fail. So this is ensuring that the object has all of these properties and only these properties. At least as far as typical object properties. Maybe some weird symbol-based, non-iterable or something like that is going on. But as far as like the typical object properties, this is ensuring that these and only these are included. So let's add a to-do here. To-do, maybe we want some kind of error behavior. This is yet another one of those tangents you could find yourself going on and feel like, I have to think about so many things at once. Well, with test-driven development, you don't have to. You can just move on. So here we are. So, okay, cool. So what would be nice? So we have multiple attributes. I think which I think are adjectives. I think grammatically that's the right word for it. We have these adjectives like big and red. I just had a thought about doing adverbs like very big, but that makes me nervous. I'm afraid to go there yet. We only have 19 minutes left on the stream. So instead, maybe what I'll do is allow for two different objects to be detected. So let's say, how would we want to do that? Say parses two objects. I was so typing to say tend to say crouching tiger, hidden dragon, but yeah, I think defining those attributes, that gets a little weird for me. So is there a Pokemon joke I can make in here? Yeah. What is that? All right, this is just dumb. Pokemon Ruby Red. I'm crazy, right? It's just called Ruby and Sapphire. Pokemon video game series. I feel like there's a game. Let's go Pikachu. Someone tell me what these... Fire red and leaf green. Yeah, there we go. That's old. Hang on. Let's do it. We got Pokemon jokes. Red fire, green leaf. And we'll talk about the period in a second here. I would like to be able to use periods to kind of separate different things. And so let's put in a period there. I think in the future I might want to be able to do commas as well, but that might get more into like what's the relationship between different objects, and we're gonna have to figure that out later. So I think a period is the simplest case. It just says these are two objects. So let's pull it out here. We're probably gonna need to add these attributes, of course, as well. Type, fire, color, red. Pokemon fans are laughing at me like, how do you not know the names of these games? I just missed Pokemon in terms of age. Like, I mean, lots of people play it, but like my interest group at the time had just moved beyond it. So I'm more of a Final Fantasy guy than a Pokemon guy. Leaf green. All right, so red leaf. So check it out here. These were missing in the middle, but it found color and type. So it's detecting a red leaf because it's skipping all these things in the middle. All right, so what can we do to move towards this working? First, we need to detect this dot here to get two different objects. So like I think first I just want to move towards actually having two different objects. So let's do that. And that's definitely something where I want to separate this out into different functions first. So I want to pull out this attribute parsing and maybe even the parsing all together. Maybe, let's see, unless it gets too crazy, I'm going to try to get it passing first and then do the refactor. So let's add a comment here temporarily. Handle attributes. And the test is still failing, that makes sense. So here we split the string into tokens, but instead let's add one extra step. Let's say const sentences. For now, sentences I think makes the most sense. Input split on a period. So then we do sentences for each. So all this stuff will happen. Const is a reserved word. Yeah, I'm gonna. Oh yeah. Sorry, I need a function here. Sentence. And now we're splitting the sentence on spaces. So this should. We'll come back to that once we resave with the syntax working. I think it'll be fine. So we've moved all this in here. So for one sentence, we get the object coming out. So instead of returning from within here, that's not what we want to do for sure. Instead, we want to have. I guess really a map would be good. Well, let's do that. I mean, that's pretty obvious already. Const objects equals sentences map. And so now we can return the object from out of here, just the object by itself, and map will include these into an array of objects. And in fact, that can just be returned. So let's just say return there. Okay, now we've made progress. So a bunch of our tests are passing. And for this one, we're getting color like red fire. We're just not getting green leaf. So the way we've coded it so far, we don't need to hard code the list of types of thing, but we do need to hard code the list of colors. So we'll just add green to the color there. Red, green, and blue. Okay, and now it's passing. So this is great. Okay, so now this is definitely so long and this level of nesting that I definitely want to refactor to extract this stuff out. So let's do it. And I think I'm going to we'll see if the linter complains, but I think in this file so far, I'm going to keep parse at the top level and then have the extracted functions that I do down below. Incidentally, if you haven't thought about refactoring too much, there's a great book, Refactoring by Martin Fowler. It's a classic book, and just in the last couple weeks, a new version of it has been released. And the language that's used is JavaScript. So especially if you're a JavaScript developer, it's great and very accessible to think about ways you can rearrange your code in small steps to make it better and make it more maintainable. So we're going to extract a function here out of the middle of this function. So I think right now the parse has to kind of split the sentences and then handle them. And so let's take this function here and extract it. We'll cut it, paste it here. We'll give it a name. I don't know if I want to keep it as an arrow. We might as well keep it as an arrow function since it's already set up that way. There's not really too much of a reason to choose one approach or another. So we'll say const parse sentence equals sentence arrow function map into this stuff. And we do want a semicolon after that. So now we'll say sentences map parse sentence. And we can save and our code still runs. So this refactoring has succeeded. We've been able to pull out this, pull this out. Okay, so now we have the attributes. So right now what's happening is the attributes are being assigned onto the object. So that would make it a bit harder to extract it out. I think what I want to do instead, ultimately I'd love for the attributes just to kind of return an object. So let's say, let's do this. Const attributes equals empty object. Say attributes attribute name. And then we'll just return. I think I have object spread on here. Just combine the object and the attributes into one thing here. We rerun and the code is still passing. So we make this one small change at a time to make sure we're moving in the right direction and things are going okay before we make additional changes. So now what we can do is extract a function that's just going to return these attributes. So let's copy this. Parse sentence. We'll call it parse attributes. I don't know if that's the best name yet. We'll say attributes. Here's the body. Return attributes there. Got a semicolon. So now we haven't, it's taking in attributes. Oh, not taking in attributes, taking in the tokens. So yeah, attributes is an object that's created here, and then we return it. But tokens is passed in. So now we should be able to replace this by saying attributes is equal to parse attributes tokens. And our test still passed, so things are still working. So this is a little bit better. We've got a parse here that splits the sentences and then parses each one. Parse sentence splits the tokens, puts the type in there, and then returns the attributes. So I think we can actually simplify this a bit. We don't need this separate object here. We can just say return type here. So we get the type and attributes, and then we include them. And when we save, things still rerun. If it runs so fast that you're not convinced that it actually worked, you can rerun yarn test watch. We're using Babel 7, which is super fast, so it works great. Return type attributes. Yeah, parts attributes tokens. Oh, check this out though. We're passing we're passing all the tokens in. Oh yeah, so check it out. So right now, this is interesting. The parse attributes function takes in all the tokens from the sentence, and it knows how to extract just the attribute values. Do we like that? I think that's kind of nice. I could see yourself pulling it out, but this works at a nice level of abstraction. In fact, to keep things even more at the nice level of abstraction, it might be good to pull this out into a separate function as well, just so that things are happening all the same way. So let's create a function, parse type tokens, and that's just going to be, so it can be useful to introduce a function to operate at a different level of abstraction, even if it's, you know, more code or more lines of code total. Parse type tokens. Yeah, so check it out. We're getting the tokens, we're getting the type and the attributes out of them, and then we're returning those in this kind of object structure. So that's really nice. Parse attributes. So how about parse attributes here? This we might be able to make shorter, probably some kind of map or reduce that happens that we could do. But I think that's fine for now. That's good enough. So it's 151. So let's think about what else we can do. So that was a good amount of refactoring we did while we were under test. We made a small change at a time to move things forward. So I really like that. So okay, so this would be good. So let's think about this now. We now have possible attributes hard-coded into this file. And that's not very reusable. Like this is, you know, the code, the algorithm of this, I want to be able to set up and have it be good to go. But attributes, like, I mean, clearly I obviously needed to add new attributes in very quickly, so I'd love to be able to pass that in instead, make it configurable. And since parse is a function, I think it would be great to be able to just add it in as an argument instead. So what let's copy the possible attributes over here into our test. We'll just put them, I found that in case we add other tests in the future, it's good to have these constants inside of the outer describe block. That way, if you're not running this file, they don't get instantiated into memory. So now we would need to make this work, we need to pass possible attributes to all the calls to parse here, and that would clutter things up. So I haven't wanted to like abstract too many details out of here, but I think I don't want to have to pass the possible attributes each time. I think maybe what we'll do is let's create another function, say configured parse. Let's do that for now. So configured parse. So what is the configured parse function? So what that's going to return is we're going to take in an input, and then we're going to return parse with the input and the possible attributes. So this is just going to, it's sort of a curried, it's probably not technically curried, but this is just a function that's going to inject some default attribute values here so that they're needed. So let's substitute this in before we do anything else. We can actually save after each one to make sure that it works. Configured parse, configured parse, configured parse, configured parse, configured parse. Okay, cool. So it's good to think about these things and add these changes in. They're going to change your interface before you move forward. Configured parse here, possible attributes is now being passed in. So what can we do with that? Possible attributes is set there. All right, cool. So now that possible attributes is there, we're going to want to pass it along. And I think what I'm going to do, I think I'm actually just going to delete out possible attributes out of this file, and we'll let the linter help us know where things need to go. Okay, so right now, so attribute names we can't define at the top level because possible attributes is passed into the parse function. So let's see where we need to move that. If I just remove it entirely, our test is going to blow up spectacularly. So we need attribute names needs to be passed into parse attributes. That means that possible attributes needs to be passed into there. So that means that possible attribute needs to be passed into there. Oops, and that means it needs to be passed into there. So parse sentence. So maybe there's a better way we could do this, but for right now, that gets us working. I'm going to put this on a second line so we can see it a bit better. Yeah. Okay, cool. So we've now managed to move the configuration for these attributes out of the file here and into our test so that it's configurable this way. And that way, this is great because this keeps this as a simple function, so we're not like hard coding in, loading anything out of a file or anything like that. Keeps our function nice and reusable because I have no idea if we'll ever use this or what context we'd use it in. So letting the containing code handle loading these attributes from somewhere would be really nice. There is a lot of passing along the possible attributes though, so there's probably some kind of currying or something like that we could do. Let's pass along from parsing everything to parse sentence. And we could call it a config. That could be one way to do it. I mean, this feels like the kind of thing that goes into options. Like the input, clearly we're parsing input, and so having that be the first argument makes sense. But I think possible attributes, like having an options object, even if we decide that possible attributes are required, I think having an options object would be nice. So it could kind of go like that. So let's make this change. There's probably a way that we could make the refactor a little bit smaller steps, but let's not worry about that right now. Let's change it from the outside in. So out here, we'll say possible attributes is the config object that we're passing in. Things are blowing up, of course. So let's do this. Config. And then here, we extract possible attributes from the config. We save and we're done. Okay, so this makes this code a little bit less tedious. We see that config is kind of passed down in these nested functions, and that seems very reasonable, something we might do. Cool. Maybe someday we'd make these separators configurable. I mean, that could certainly make sense. But our tests are not driving us there yet, so I think we're fine. Even things like slice and tokens length -1. Let's do that as two quick refactors. Again, certainly, of course, if you're using a utility library, you could pull these out. But even having things in small functions encourages us to do this to make things readable. So I might say here, we have a last, take an array, and we return array length -1. We say last of the tokens. That still works. Let's move this utility-ish function down to the bottom. And then, so how about slice -1? It's like, what's a good short name for that? Maybe we call that remove end. Remove from end, array, we'll say num to remove. Even just that makes it more readable. We'll say array slice 0 and then negative number to remove. Maybe that'll blow up, but not in our test cases that are handled now. So remove from end. Remove 1 from the end. And you know what? Just to kind of feel like a functional programmer, we'll put that configuration there. Remove 1 from end tokens. And it passes. I'll put this on another line. Of course, remove, in a sense, sort of implies mutation. We can rename that in the future. One other quick note here. So notice that the parse function is the only function we're exporting, and we haven't tested any of these individual component functions. These functions are kind of private to this module, and they're not exposed. So you might be wondering, like, how can we test these functions? And the answer I would give is that you don't test those functions. It's a good idea when you're testing to test only the outside interface of the object or of the module that you're testing. So our test code cares how the parse function works. It doesn't care about how things are organized inside. And that's what's allowed us to be able to refactor this easily. And so I'd encourage that approach. I mean, this refactoring has been really fun, and it sets our code up to be much more understandable in the future as we make additional changes. So I encourage not exporting all these component functions. If you find that you want a separate utility file, maybe you export these and test them, or if they're reused in multiple places. But as it is, it doesn't seem necessary. So this has been our test-driven development. There's so many other places we can go. We've only gotten to the point of saying red fire, green leaf. Maybe in a future stream we'll kind of go deeper into this. It certainly would be cool to take this further. Maybe I'll even learn some 3D programming someday and talk about a yak shave. It's like, let's invent natural language processing rather than having to learn how to use a 3D modeling program. So good times. But that's the life of a programmer, is yak shaving. I could use some shaving here myself as well. So everybody who joined in real time, especially Ken Bear, who said hello, thank you so much for joining. If you're joining on the recording afterwards, thanks for checking it out. I hope this was interesting to think about how test-driven development can work for an individual function. So whether you've got something big and hairy like this, hairy like a yak, or something much more small and approachable, think about doing test-driven development for your application, for your individual functions, when they have logic like this. Logic where you don't know the implementation, and you know the implementation might change, but you know the inputs and the outputs. Or maybe you even want to explore the inputs and the outputs as you go. So give it a try. Once again, I'm Coding It Wrong, aka Josh Justice in Human World. Thank you for joining in, and we'll catch you next week for some more streaming about JavaScript and development and probably testing. And we'll see you next time. Let's go to the slide. See ya.